Something is moving through our solar system right now that breaks every single rule of physics we thought we understood. It appeared out of the dark, silent, and unannounced. A faint streak of light sliding between the orbits of the outer planets, moving faster, brighter, and far stranger than anything we've ever tracked. They call it 3I Atlas, an interstellar visitor, a wanderer that refuses to behave like a comet, a rock, or anything born in this solar system. From the first images, it was clear this was no ordinary object. Within days, astronomers began to notice impossible behavior, its color changing suddenly from crimson red to luminous green, as if reacting to something unseen. Then came the beam, a razor-thin shaft of light, firing straight toward the sun instead of away from it, like a cosmic spotlight defying every known law of motion. And as the data poured in, one more pattern emerged its trajectory, perfectly aligned with the ecliptic plane, threading through the paths of the planets, with surgical precision, as if it knew exactly where it was going. Scientists tried to call it coincidence, but deep down, no one was comfortable saying that out loud. If it can aim at Mars with precision, what happens if it decides to aim at Earth? Because if what astronomers are seeing is real, this may be the first object not just from another star, but from another mind. In the quiet language of the cosmos, most comets follow the same script. They warm up as they approach the sun, their brightness rising in smooth, predictable curves. But 3I Atlas refused to play by the rules. It brightened like a flashbulb, then went dark again, not over weeks or days, but within hours, as if someone were flipping a switch in deep space. According to preliminary readings from JPL's tracking data, its luminosity changed by more than 250% in under 6 hours, a fluctuation no natural comet has ever displayed. Scientists scrambled for explanations. Could it be jets of gas venting from beneath the surface? Or a burst of dust reflecting sunlight from strange angles, yet none of the models fit. The jets weren't consistent. Their direction shifted randomly, sometimes even against the expected flow of solar wind. It's like watching a heartbeat in deep space pulse. Fade. Pulse again, as though the object itself were alive. Breathing through light. For the first time, even seasoned astronomers began to question whether they were looking at a comet or a signal, and then it did something that made every astronomer stop breathing. It fired a beam toward the sun. When the Hubble Space Telescope locked its gaze on 3I Atlas, it captured something that shouldn't exist: a long, narrow streak of light pointing straight toward the sun, as if the object were defying the very breath of the solar wind. To the untrained eye, it looked like a beam-focused, deliberate, and almost weapon-like. But scientists knew that comets aren't supposed to do this. Every tail ever observed in 4 billion years of solar system history points away from the sun, blown backward by radiation pressure and streams of charged particles. What Hubble captured was something different. A forward-facing jet, a column of gas and ice erupting from beneath the surface, escaping through fractures that happened to point directly toward the sun. Picture it like this: the comet's tail always points away, but its jets can shoot in any direction depending on where the surface cracks open. NASA and Live Science once noted a similar forward jet on another interstellar traveler too, I Borisov, though it was faint, fragile, and barely measurable. 3. I Atlas, however, is something else entirely. Its jet is 10 times longer, 10 times brighter, a cosmic spotlight shining into the wind, daring the sun itself to explain it. And the deeper scientists looked, the stranger it became its chemistry makes no sense. Every comet we've ever studied follows a simple recipe ice, rock, dust, and frozen gas. Astronomers call them dirty snowballs, because most of their mass is just frozen water mixed with cosmic debris. But 3, I Atlas breaks that rule completely. When its spectrum was analyzed, scientists didn't find water ice as the main ingredient. They found carbon, lots of it. 87% carbon dioxide, 9% carbon monoxide, and barely 4% water, an upside-down composition that makes no chemical sense for a natural comet. It's as if someone mixed the ingredients wrong and created matter that shouldn't exist. Harvard astrophysicist Avi Loeb noted this same anomaly in early JWST data, though he was careful to say the results are preliminary, not yet peer-reviewed. Still, the pattern is unmistakable. A comet rich in carbon dioxide, but starved of water, like a snowball made of fire. Some researchers suggest it could be a measurement glitch, or a quirk of reflected light caused by ionized gases glowing under solar radiation. But even if it's an error that repeats every new observation, shows the same strange signature. And if those readings are real, then the laws of comet chemistry just broke. But then, something even more impossible showed up metal. When the chemical readings came back, one detail stood out, traces of nickel, but no sign of iron. In space, that's not supposed to happen. Nickel and iron are cosmic twins forged together in the hearts of dying stars, born from the same nuclear reactions, and almost never found apart. Wherever you find nickel, iron should be there too, bound by physics, chemistry, and 4 billion years of cosmic habit. So when 3 I Atlas showed nickel without iron, scientists were left with only 2 possibilities. First, it was born in an environment so exotic, so unlike anything in our solar system, that it rewrote the chemistry of formation itself. Second, it wasn't born at all. It was built. As Avi Loeb from Harvard put it, if it's built, not born. We're no longer just talking about astronomy. Finding nickel without iron is like finding a magnet that repels gravity. It just shouldn't exist. And Harvard's most controversial scientist decided to say it out loud. Few names stir debate in modern astronomy like Avi Loeb, the Harvard astrophysicist who once claimed that the interstellar object Oumuamua might not be a rock, but alien technology. Now, years later, Loeb has turned his attention to 3, I Atlas, and what he's suggesting has once again shaken the scientific community. His hypothesis is simple, but unsettling. 3, I Atlas might be a technological mothership, a carrier releasing smaller reconnaissance probes as it passes through our solar system. Loeb points to a curious pattern in the data. Each sudden spike in brightness seems to coincide with the appearance of new smaller objects, like 2025 R2 Swan, which some believe could be detached fragments or even deployed probes. In other words, the flare-ups might not be random explosions of gas. They could be deliberate actions. The light curves show repeating intervals. Consistent timing, not chaos, but coordination. Brightness spikes like coded signals as if something's talking. Not just glowing. Coincidence. or coordination. And to make things worse, its flight path looks planned. Most interstellar visitors that pass through our solar system arrive at wild, chaotic angles. Some diving in steeply from above the ecliptic. Others slicing through from below, like cosmic debris thrown by distant stars. But 3, I, Atlas, is different. Its trajectory runs almost perfectly parallel to the ecliptic plane, the thin, invisible disk where all the planets orbit with a tilt of less than 5 degrees. That kind of precision is unheard of for a natural interstellar object. It's the celestial equivalent of threading a needle blindfolded from millions of miles away. Even stranger, its route brings it close enough to Mars for perfect observation, yet carefully distant from Earth, avoiding any chance of collision or panic. To some, that looks like intelligent navigation, a calculated flyby meant to study, not to strike. Others argue it could simply be chance, a retrograde orbit that happened to line up with our planetary plane by coincidence. Nothing more? But even skeptics admit the math is unnerving. The odds of such a near-perfect alignment happening by chance are astronomically small, and its timing couldn't be more suspicious. Just wait until you see what happens in October. October 3rd, 2025, the date. Every space agency has circled in red. On that day, 3I Atlas makes its closest approach to Mars. NASA, the European Space Agency, and the Mars Reconnaissance Orbiter have all been quietly preparing for this moment, repositioning satellites, recalibrating sensors, and clearing observation windows. The goal is simple but historic: to capture the first ever image of an interstellar object not from Earth, but from another planet. From its orbit around Mars, the HiRISE camera will have a unique vantage point, roughly 30 million kilometers from Atlas. With an expected resolution of about 30 kilometers per pixel, it's not sharp enough to see fine structures, but enough to reveal the truth is that eerie glow, reflected sunlight, or something generated from within. Scientists call it a once-in-a-lifetime alignment, a fleeting moment where human technology and cosmic mystery cross paths above another world. One picture could rewrite everything, but after Mars, it turns straight toward the sun. The story of 3I Atlas doesn't end at Mars. It's only entering its most critical chapter. Between October 29th and 30th, 2025, Atlas will reach its perihelion, its closest point to the sun, about 1.36 astronomical units away. But 48 hours. It will pass directly behind the sun, completely invisible to every telescope on Earth. No signals, no images, no way to know what it's doing. Just silence. Astronomers believe one of two things could happen. The first, it disintegrates, vaporized by solar heat, leaving behind a trail of debris, like a dying ember fading into the solar wind. The second, it survives stable, intact, and perhaps even brighter, triggering one final outburst before vanishing into the void. By December 19th, it will have left our cosmic neighborhood drifting beyond 1.8 astronomical units from Earth, on a trajectory that may take it out of the solar system forever. Whether it burns, breaks, or endures, one thing is certain: we won't see anything like it again in our lifetime. And when it re-emerges on the other side of the sun, the first question everyone will ask is the same: did it just pass through? Or did it send something back?